Hello learners, welcome back to my channel Maths Made Easy with AB. So this is a video, it's a continuation of the domain that we have seen in my earlier video. If you have not seen the earlier video, do watch it and then you can continue watching this video. So basically in this video we will be seeing some of the important numericals related to domain. So this is a series which we are continuing of function y is equal to fx. We are understanding all the aspect of a function, how it is defined, what is the domain, what is the range, how to draw a function, how to draw a graph. You can see my series play with the graph, wherein there are around 10 videos wherein you will find everything about how to draw a graph, how to understand which is the function, which is not. So basically let's continue this video by the question that I had given in the previous lecture, 1 by fx is equal to 1 by greatest integer function x minus x. So basically, and this is the greatest integer function, so it was also written that this is greatest integer function of x. So now students understand this problem. This is very simple. So what we have to do is, we knew in the previous video that if there is a square root of some function fx, so no, not like, let's not write it this way. So if something is given, some x square plus x plus 1. So under square root, if anything is given, a even square root, so this part has to be greater than or equal to 0. If it is in the denominator, denominator cannot be equal to 0. So using this concept only we can solve this problem. So now see how to solve this. So basically here you can see that this part under the root should have been greater than or equal to 0. But can it be equal to 0? No, it cannot be equal to 0 because this part is in the denominator. So I am removing the equal to sign from here. Right, students? So this is the basic thing that forms, and you have to find the x to find the domain of this function y is equal to fx. So here you see greatest integer function x is greater than x. Now this is the thing that you get. How to solve for x, students, over here? Now see, we have already seen greatest integer function. If you have not seen the video, I will be giving it in the description. Greatest integer, for we have seen greatest integer function, we had seen least integer function, and we had seen signum function in a lecture whose video link I will be providing in the description. In the play with graph, we have seen in detail about these functions, so I'm not going into this. In the play with graph also, and few parts we have done in the initial functions also. So let's not move into this right now. Assuming you know what is greatest integer function and giving you a brief over here. So basically, if 1.67 greatest integer function is asked, its value will be 1. So basically, if I and I plus 1, right? I is integer plus 1. Say for example, if this I is 5, I plus 1 will be 6. And if some number is lying between I and I plus 1, this will take this number. If a number fractional part of this has to be found out, so it will be I only, integer. And if I plus 1 has to be found out, then it will be I plus 1 only. But a number lying in between I and I plus 1 will take the previous value. For example, greatest integer function of 1.67. So basically I will be 1 and this will be 2. And since 1.67 lies in between 1 and 2, so the answer will be 1. If, say for example, it would have been, say for example, x would have been 6.23. So this lies in between what, students? 6 and 7. So the value will be for the greatest integer function only what? It will be 6. So we have already seen this earlier. Now understand, students, it is saying that greatest integer function of x is greater than x. So if it is of 6, value is 6 only. Yeah. So say for example, value is 6.23 only. Let's see, let's put it in this equation. So 6.23, so this will be 6.23, greatest integer function will become 6. And this will be greater than x is 6.23. Is it true, students? No, 6 is not greater than 6.23, right? So basically understand this, what I did over here. I'm just erasing everything. Say for example, I take the value of x as 6.78. 6.78. So what will be the greatest integer function of the, students? 6. Now putting this into this equation just to check. So basically 6 is greater than 6.78, which is not true, Now so it means x cannot be any fractional number. Can x be integer number? Say for example, I take x as 6. So greatest integer function will also be 6. So 6 is greater than 6. Is it true? No, it is also not true. Hence, here x will not have anything. So x belongs to null set. There will be no values of x defined for this function. So for no values of x, you will be getting any value of y. So this is the domain of the function that is given over here, that I had given you to solve on your own. I think students, if you have understood the concept, you would have solved this problem. Else you learned an important concept over here. Now let's move into the next part. Let us see another question, how to solve domain, how to get answers of domain if they ask you. So the next question let's solve is, find the domain of the function y is equal to fx. Y is equal to fx is equal to root over 2x plus 1 upon x cube minus 3x square plus 2x. So this is the question, students. So now if you see this question, for students who have understood what functions are and how to find the domain, I'll ask you to pause this video over here, pause the video over here, and try to solve it on your own, get the answer of x, and then see whether it is matching or not. If this doesn't match, I'll request you to see the solution of this problem. So now let's see the solution of this problem. So understand, students, what is here is under root is given, right? So this entire part should be greater than equal to 0, right, students? So the first part will be 2x plus 1 upon x cube minus 3x square plus 2x is greater than equal to 0, right, students? Anything under the square root should be greater than equal to 0. Now you know that denominator part, x cube minus 3x square plus 2x cannot be equal to 0. So this is another equation that you get, right? You have to solve this, you have to keep that in mind also. So you have to keep this in mind also, and you have to keep this in mind also, and then you will have to find a solution for this problem. So now students, understand, if I take 2 common, I have taken 2 common and I am removing it, okay? So x plus half, so this is 0, so it cancels out if I take 2 common from that, right, students? So I can write it x plus half. Now if I take x common from here, so x square minus 3x plus 2 greater than equal to 0, right, students? And let's solve this also. So x common, x square minus 3x plus 2 is not equal to 0. So x into, if I factorize this, we get what? X minus 2 into x minus 1 not equal to 0, which means what? X is not equal to 0, 2 or 1. X is not equal to 0, 2 or 1. You can write it 1 or 2. So 0, 1, 2, x cannot take the value is what I get from this part. Right, students? So I can write it, x is not equal to 0, 1 and 2. So I can write it separately. So these are a set. X cannot be of 0, 1 and 2. I write it down over there. Now students, let us see this one. Let us be seeing this one. So I solve this. Let's remove this side, this part which we have already seen. So now students, understand this, how to solve. So this is x plus half, and this is x into, same thing, x minus 1, x minus 2 greater than equal to 0. I factorize that one same way that I did earlier. So now this is wavy curve. If you have not seen my video on wavy curve, it is highly recommended. Wavy curve. Simply, I'll give you the description also about wavy curve. If you have not seen this video on wavy curve, do watch the video. Else, just find out, you can search it, wavy curve, Maths Made Easy by AB. So you will get that video. Wavy curve, there are 2 videos I think, and you need to watch those to solve any problem upcoming in functions and calculus. So basically we will be moving from here to calculus. So domain, range, limits, these are the basics of starting calculus, and then application of derivative, integrals, and also these forms part of calculus. So now here you get what are the critical points, students? The critical points are minus half, 0, 1 and 2. So these are the critical points. Minus half, 0, 1 and 2. These are the critical points. Basically, if you have not seen my wavy curve video, you have to equate each portion to 0. So if I equate this to 0, I get x is equal to minus half. If I equate this to 0, I get x is equal to 0. Equating this, I get x to 1, and equating this, I get x is equal to 2, which forms the critical point, not the value. So now I am plotting it on the number line, minus half, 0, 1, 2. So simply all powers are what? All powers are odd. So every time it will shift the side. Every time it will shift the side. This will become the curve. This will become the wavy curve for the question. Students, if you have not seen wavy curve, I will not go into details. Do watch and then come back. Upper part is plus and lower part is minus. Upper part is plus and lower part is minus. Now students, what? Greater than equal to 0, so we have to take the positive part. So x belongs to minus infinity till minus half. X belongs to minus infinity till minus half, greater than equal to, so basically we have to take this. We have to include minus 2, union 0 to 1, union 0 to 1, both included, union 2 till infinity, union 2 till infinity, union 2 till infinity. So this is the solution. This is the solution that comes out by solving only this part, this portion, students. Now I have already told you, for a function fx, you have to see the other part also. You have to intersect this. So x cannot be equal to 0, 1 or 2, students. So what will be the answer? What will be the final answer? X can be minus half, x can be 0, no. So I cannot take this bracket. I cannot take this bracket. I cannot include 0. Can I include 1? No, I cannot include 1. So this bracket will also be like this. Can I include 2? No, I can't include 2 also. So this bracket will be like this, students. So this is the answer. This is the domain of the function that has been given over here. So this is the domain. This is the final answer of the question that you see. I think, students, this question has cleared your concept, all the basic concepts regarding domain. Let us now move and see some of the logarithmic functions, how to find the domain if you get some logarithmic functions. Students, if you are liking my videos, do subscribe to my channel such that I'll bring you more informative, conceptual based videos so that you can crack any numerical that comes in joint entrance examination. Also, students, this is an important for anybody in class 9, 10 who are watching. They can also strengthen their concept by seeing these videos. So let us see the next question. Find the domain of the function y is equal to 1 by log 10, log base 10, 1 minus x plus root over x plus 2, root over x plus 2. So this is the question, root over x plus 2. So this is the question, students. If just let me write it down, plus root over x plus 2. So I think this is visible to you all. Yeah. So now what will be the function? So you have to define this function so such that you have to find the values of x so that the function y is equal to fx is defined. So now here you see, you remember for log, y is equal to log x base a. To define this, I had given you the rules of when you find domain. So what was the log rule? So log rule was x has to be greater than 0. X has to be greater than 0. A has to be greater than 0. And a cannot be equal to 1. And a cannot be equal to 1. So these were the logics. These were the logics when it comes to log. Now, students, what is the value of a over here? What is the value of a over here? The value of a is 10. The value of a is 10. So is 10 greater than 0? Yes. Is 10 not equal to 1? Yes. So you need not bother about these two conditions. These two conditions are already fulfilled. So only condition that you will have to think about over here is 1 minus x. 1 minus x should be greater than 0. Only 1 minus x means x, right? This part, log x. So x here is 1 minus x. So 1 minus x has to be greater than 0. Has to be greater than 0. So basically, if you write 1 is greater than x, so x has to be less than 1. So this is the part that you are getting from here. X is less than 1. Students, I think this is clear to you all. Another important thing over here is, I am erasing this part. So now this is in the denominator. So tell me, students, log 10 1 minus x, this shouldn't be equal to what? 0. Denominator. So basically applying that denominator is not equal to 0 principle. Denominator is not equal to 0 principle over here. So log 1 minus x base 10 is not equal to 0. So now how could you solve it? 1 minus x not equal to 10 to the power of 0. Students, you know this theorem, right? If log a base b equals c, then I can write a is equal to b to the power of c. Then I can write a is equal to b to the power of c. Simply I have applied this. So 1 minus x is equal to 10 to the power of 0. By this formula of logarithm, I think logarithm is a very basic thing. I'll make a video on logarithm and post it so that these things are cleared. If you already know, well, good enough. Let's move further into this problem. So basically you are getting 1 minus x is not equal to 1. So what you are getting, x is not equal to 0. X is not equal to 0, students. Understand this part, x is not equal to 0. Now, which means if I combine both of these, so it becomes x is less than 1, but it cannot take the value of 0. X is less than 1, but it cannot take the value of 0. Till now we have got this. Now students, this is a function fx, right? So this one part was, say for example, hx, and this one was, say, gx. Now we have to see gx also, and we have to intersect this with what is the value that we are getting for gx. We have already seen in the previous video, fx plus gx, right? So let's make it simpler. Let's remove gx and all from here, and what you have got from here, let's write it down somewhere. What you have got from here means what you have got from this function is x is less than 1 minus 0. This shows that it cannot take the value 0. This is the set value. We have removed 0 from here, right? So now let's erase this part and go to root x plus 2. Very easy. Already you have seen. So root x plus 2, what x plus 2 has to be greater than equal to 0. X plus 2 has to be greater than equal to 0. It is not in the denominator, so equal to will come. So x is greater than equal to minus 2. Done. Intersect this and this. What we will get? X is great. So I'll write it like this. X belongs to minus 2 included, minus 2 till 1 not included, minus 0. You can write it in this way, minus the element 0, right? I think students you are getting it, because these are very basics, and now we have moved deep inside understanding all the basic concepts. So this must be clear to you all. So domain of this function that is given y is equal to fx is this. You can also write it in this way. X belongs to, let's break it, minus 2 till 0, 0 not included, union 0 not included till 1, 1 not included. So this or this, whatever you write, both are the same thing in board examinations. In maybe joint entrance you can get any of these options, so you have to be very clear which one is the answer. If you are confused what answer they have written, then you will be in big trouble, students, right? So now let us move into the next problem. Let us now move into the next problem of finding domain. I think till now this video is turning out very useful to you all. For students who are starting solving domain, it will be a request for me that first solve numericals that are in R.D. Sharma or R.S. Agarwal, and then finally start solving numericals that had come in AIEEE, JEE Main, JEE Advanced or IIT previously, so that your concept becomes extremely clear. And let me tell you students, this is a very important chapter that comes in joint entrance examinations, right students? So let us move into the next problem. So the next problem is find the domain of the function. So let us involve trigonometric function over here. So y is equal to cos inverse 1 minus 2 mod x upon 3. 1 minus 2 mod x upon 3 plus log mod of x minus 1, it is in the base, and here it is x, and here it is x. So this is the next question that has come in. Y is equal to cos inverse 1 minus 2 mod x by 3 plus log of x with base of mod x minus 1. Students, now understand very important part over here. So I'll give you some basic concepts. So you all know that y is equal to sin x or y is equal to cos x. Both of these functions lies in between minus 1 and 1, both included, right? So if you get, so basically sin x, so you can write x is equal to what? Sin inverse y. So sin inverse, this part y will lie in between what? Minus 1 and 1. This is the value, right? Y, the output value lies in between 1 and minus 1. So this part, I can write x is equal to sine inverse y. So this part, that is internal, will have to always lie in between what? Minus 1 and 1. Why? So basically I am saying that this part that you can see has to mandatorily lie in between minus 1 and 1 for cos or sin x. So understand these problems. These problems involve this concept. So I told you the concept that is needed for this problem. So let me highlight from here only. So what I am saying is 1 minus 2 mod x upon 3. This will lie, for this function to be defined, this function will lie in between minus 1 and 1. This function will lie in between minus 1 and 1. Students, I think this is clear to you all. I think this is clear to you all. This function will lie in between minus 1 and 1. Right, students? So understand, let's start solving this problem. The next step what you will get is 1 minus 2 mod x. So 3 will move this side. So let me write it this way. 3 will move this side, so this will be minus 3 and this will be 3. Yeah. So let's see, 2 minus 2 mod x will be minus 4 and this will be 2, students. Now the next step, so let's cancel out 2. This will be minus 2 and this is minus mod x and this is 1. So minus mod x is lying in between minus 2 and 1. Now if I remove minus, so what you will get is the signs will reverse, right? So this will become 2 mod x and this will become what? Minus 1. So students, now understand this part. We have solved it till this part. I think this is very clear. Now mod x is always greater than minus 1. I have already said that mod x, the graph is hard. What? Like this. So this always like the value of y is equal to mod x is always greater than 0, right? So it will mandatorily be greater than minus 1. So it will be mandatorily be greater than minus 1. Right, students? So let's now move from here. So I'm just writing what we got. So we have reached this step 2 greater than equal to mod x greater than equal to minus 1. Right? And I'm erasing the solution that we saw over here. I'm erasing this part for clarity, for more clarity. So this part, right? And mod x is always greater than minus 1. So basically you have mod x is less than equal to 2, students. Mod x is less than equal to 2. So this part, only this part. So 2 is greater than mod x. So mod x is less than equal to 2. So I can say x lies in between. So I can say x lies in between minus 2 and 2. X lies in between minus 2 and 2. We have already seen this numerical, students, in modulus chapter, in modulus series. If you have not watched the series on modulus, it will be a request to see that series. So this is y is equal to mod x and this is the line y is equal to 2. So this will be minus 2 and this will be plus 2. So x will lie in between this side if it has to be less than y is equal to 2. So this is what the solution I have made. I am not going into details. Watch my series on modulus for this solution in details. There are several videos that I have made over there. Yeah. So this is the solution that you are getting, x lying in between minus 2 and 2, students. I think this is clear till now, because this part mod x greater than minus 1 is always true. This part is always true. So I'm not taking into that, right? Right, students? So let's omit this part. And remember, this is the solution that we are getting from this. So from this we have got x lying in between minus 2 and 2. Right, students? So this is fx plus gx. Let's solve for this. So this is simple log x, right? So here x has to be greater than 0. X has to be greater than 0 and mod x minus 1. This has to be greater than 0 and mod x minus 1. This cannot be equal to 0. So that is basically a that we already saw. A has to be greater than 0 and a cannot be equal. A has to be greater than 0 and k cannot be equal to 1. Sorry, a cannot be equal to 1. So these are the things. So I think you all have understood that mod x minus 1 greater than 0. So this is one thing, and mod x minus 1 is not equal to 1. So basically over here what you will get is x, if you solve this, you will get x not equal to, so if you remove mod, plus minus 1. So x is not equal to 0 and 2. X is not equal to 0 and x is not equal to 2 is what you get from this. So x minus 1, remove mod, plus minus 1 it becomes. So x is not equal to 0 and x is not equal to 2 is what you get. Mod x minus 1 greater than 0. Solving this students, again, if you don't know how to solve this, do watch my series on modulus for knowing what is the solution. So here it will be x belongs to real minus the number 1. Minus the number 1. I think this is clear to you all. So x minus mod x minus 1 greater than equal to 0 if x is right students. So let's not write it and complicate it in this way. So mod x minus 1 is greater than 0. So this part is always 0, right? This part is always positive because this is modulus part. So mod of any part, will it always be greater than 0? Yeah, it is always greater than 0. But students, this is greater than 0. I'm just explaining it to you what I wrote earlier. So say for example x is 1. So 1 minus 1 will become 0, right? So this part is all real minus the number 0. Minus the number 1. It cannot take the number 1, else it will become 0. 0 is not greater than 0. So by that logic, r minus 1. Right students, now let us see the intersection. So minus 2 till 2, this is real minus 1, so 1 cannot be the value, 0 and 2 cannot be the value. So students, what will be the value? I am writing it down. 0, is it included? No. 0 till 1. 0 till 1. I think this is clear to you all. 0 till 1 union 0 till 1 union 1 till 2. 0 till 1 union 1 till 2. Why I did that is very simple to understand. Right students, I think you are getting what we have done. Right, so this I took greater than 0, I am intersecting this part. So this is one part, this is the second part, this is the third part, and this is the fourth part. So intersecting all these four, we are arriving to this answer. So this is the answer for this question. Students, so this was a very important question of logarithm. If you see this question, this is very important because here we saw this involved actually trigo function also. So you found, so if this would have been sine inverse, so the concept wouldn't have changed. That is my point. Now students, I will be ending logarithm right over here. Sorry, not logarithm, I will be ending domain right over here, finding domain of a function. So it will be my request. I already told you while we were solving this problem that go through numericals of R.D. Sharma, R.S. Agarwal. If you find any doubt, you can go to the comment section, you can post it. We will try solving this in a video, or individually I will be replying it to you, or maybe I will be providing the solution. If you like the video students, do subscribe to our channel, do like this video, do circulate it in your circle to your friends who are watching, who are preparing for JEE mains and advanced or any competitive examinations. Thank you all for your time. Thanks for watching.